Hello, my name is Eugene Hanley, and I will be explaining the difference between polling and interrupts. Um, Start with polling. Polling is a process in which a CPU constantly looks for a change in the status of a device or poll. Until that's given, the CPU cannot continue its operation. That will slow it down because it's waiting for something to happen. When it reaches that or receives the condition that was given, it will then continue on to the next program and then follow from there. Um, I have set up my MSP 430. It's running here. We have a program that is in assembly. Um, this will demonstrate how polling works. All right. So first, we'll clear the stack pointer and the watchdog timer. Um, That'll allow it to tell the program where it's gonna keep the information and allow us to write to the processor. All right, the first step would be writing into memory the um, pull one resistor. We allow it to enable itself, allowing it to change the voltage to our output. As you can see, the P1 RIN has changed now to 08. Um, as it keeps the information in there. Next will be P1 out, which will allow the resistor to know where to start from when we run our program. So you can see the pin out has now changed and the pin in. And next we will change the director, which is tells the output or the LED which one to light up. And now in the main program here, let's see when the first button is checked, it will the first thing is a bit check, which will see if the button has been pressed. It's currently not pressed, so what's going to happen is it's not going to find it, and it's not going to create a carry, and because of that, it will loop back to the main program. Yeah. Now I will press the button, and as you see, the PN has changed. It has now also created a carry. As you see there. So now because of that, it will move on to the next step, which will be actually adding memory to register 5. All right. Now in register 5, it normally is set to a much higher value, but for the sake of time, I lowered it to only start with an A value in hex in the location 5, as you will see here. There you go. It's only set at A. Now from there, it will count down 1 every time I cycle through until it hits 0. And when it hits 0, it will create a flag in the the 0 condition, which will then allow it to move on to the next part of the loop. All right, still counting down. All right, now we have 0. Now it should skip into the next part of the loop, which it did, which is the same check that I had in the beginning. This one will check to see if the button is pressed. I have pressed the button. So it will then check for the carry, which it will not, it will find, then it will move on to the next step, which is to XOR or change the bits for the output, which will toggle it on and off. This one, since it was off, should toggle it on this next press. There you go. So now it is on. The flag is at 48, which is the opposite of what it was. It's inverted. And After this, it will jump back to the main loop and start the program all over again. And then you will cycle through it again, and then this time it'll turn itself off. And that is how polling works. It looks for something, it keeps looking for it, and until it receives it, it does not continue on the program. Okay, now we're on to the the interrupt side of this demonstration. Interrupts, they work differently than polling. Interrupts, they're set into the memory. Um, they're used when an event is sent to the CPU. Um, what that would do is it causes the CPU to stop whatever it's doing and do the interrupt. And when the interrupt is completed, it will go back to where it last was at and continue on into the program. All right, first thing you will notice here is that the interrupt vector is set to port 1 or P1 ISR. It has been set into the memory. That is the commands that will be sent to the CPU when we hit our interrupt. All right, so let's begin the program. First, we're going to clear the watchdog timer and start the stack pointer at its location. Okay, now the first step will be to set the green LED to the output. That should come up into the directory, and there we go at 4. Next step, we will enable the resistor that will work off of the button that will send the interrupt. All right, we set that to out. The next step will be to add a resistor to that, a pull-up resistor. That should set it to 08. There we go. All right. Next thing will be to enable the port 1, which will allow us to run our interrupt. All right, we did that too. It's been set to the same button as the others. Next, we'll set the edge for when it will interrupt on the change between 0 and 1. There we go. Okay, next will be to clear the interrupt flag so that when the CPU will know when an interrupt has been sent. There we go, now it's a 00. This will start all the interrupts, which will allow us to then send the command. All right, and now it jumps to the last hex, so it's not actually going to go anywhere. It's going to stay here and wait for a command. But if there was something else, it would keep running. Then if we send the interrupt with the button, it will then send the interrupt instead. All right, now I will quickly run through each program to show you that they do exactly what they're supposed to do. This is the assembly for the polling. As you see, the changes here, setting up the bits. All right, you see the loop that will not let me clear it. By holding down the key here, we have now cleared it. All right, run this until it hits 0. All right, now at this point, we are going to receive the change in the XOR that will allow the light to turn on and off. As you see, it did. And now we'll jump back to the main loop. All right, the the interrupt. So as you see, I defined the button in the LED, the same directory output, and enabled the resistor. Then I enabled the interrupt. It waits for an interrupt to be sent. There's the location of the interrupt. And what it does is it will toggle the LED to whatever the opposite is, and then it will reset the interrupt and start over. All right. Now I'm going to run this program. And as you see already, we have the light. With each click, it will interrupt, send interrupt, and then reset, and send. All right, the next program is the assembly for the interrupt. As you see, it's been set. We got the moves, the sets, clears. It will enable it, and then it will wait for a command. Here is our interrupt that it will be sent. It's going to change the LED, and then it's going to reset the flag, and then return for the interrupt. And our interrupt vector is at port 1. All right, now I'm going to run this program. Okay. And now, as you see over here on the side, it is waiting for an interrupt, which I will give it, which will then turn on the LED. Then I'll send another interrupt, and it toggles it off. All right, and for my last example, I have a C code here of Poland. As you will see, it's the one with the delay cycle in it that will wait for a certain amount of time, and then if the button is still pressed, it will run. As you'll see, I'm just going to start the program. All right, now as you see over here, it should just toggle as the time runs. All right. And that is my presentation. Thank you.